Alright guys, welcome back. Our objective right now is to integrate DMVPN with MPLS VPN. Right now, just like we had done earlier on, this is based on the same topology. I have my service provider in the middle, the yellow one, and then I have a customer which has four different locations: Dubai, London, Los Angeles, and New Delhi, which are connected to each other over the service provider MPLS network. One of the things that happens with an MPLS VPN network is as a customer, I share my routes, my internal routes, with my service provider, who in turn will send it to my other sites. Now, by the introduction of DMVPN into this setup, I gain two advantages over here over the way I have set it up. Right now, I'm exchanging my routes with my service provider, so my internal networks, which in my case over here, for example, on R5, I have two internal LANs, which I'm simulating right now with loopbacks. I have the 10.5 and then the 10.55 network. These two networks behind R5. Similarly, I have 10.6.6.0 and 10.66.66.0 as my two internal networks, which are behind R6. I'm sharing them with my service provider, which in turn, again, he does isolate it and only sends it to my customer site, but the fact is I am sharing those routes with my service provider. If I want to hide those routes from my service provider and just send it towards my other sites, the other sites that belong to me, I have the ability to set up DMVPN between the sites, between the four sites that I have. Let me just put this in over here. So I have the ability to set up a DMVPN setup where I'm going to use the service provider network just for the reachability sake of my DMVPN. So basically what I'm going to do is I want to set up a DMVPN over here, which allows me the ability to use, let's say, Dubai as my headquarters. I'm going to use the reachability through the MPLS VPN, which is basically 192.1.15. I can use that network, or I can introduce a new network into this routing, so I have the ability to connect up to the other sites for my DMVPN setup. Okay, but my main objective over here to set up DMVPN is not just hide my internal networks, which are my 1055 and 5 networks. My other objective is not only to hide my control plane traffic, but also my data plane traffic. Not just the routing information about my routes, but the actual data that goes between 10550 to all the other networks that I have. I want to be able to hide that from the service provider, the data portion as well. So with DMVPN, I gain two advantages. One, I keep my private networks private. I don't share them with my, I'll write that down in your notepad. I'll just get rid of this over here. So a couple of advantages that I gain by doing this over here is number one. So the advantages of setting up DMVPN along with the MPLS VPN private WAN setup that you have. The two advantages: number one, hides the internal networks from the service provider. Number two, it encrypts the data from the internal, from I would say just from the sites to sites. But I also want to have the ability to go from anywhere to anywhere. That's why I'm going to implement DMVPN with NHRP NHS. I'm pretty sure you guys have done that. My objective over here is more to show you the collaboration of MPLS VPN with DMVPN. If you would like to go into a detailed lecture about DMVPN, I can do that as well. Probably create a video, send me an email. My email address is khawarb@khawarb.com, and I'll share that video with you that goes into detail about how DMVPN is set up. My main objective of this video is to integrate MPLS VPN with DMVPN. So To do that, the first thing that I'm going to do, and I don't need to do it, but I could have used my addresses that were assigned to me by my ISP. That's the 192.1.15 or the 26 or the 37 or the 48 networks. But just so that I want to do it based on my own addresses, that's also going to help me for my next series of the next video in the series. That's the MPLS with using the IVRF. I'm going to use a loopback address that will be used as my source address for my tunnel interface. But before I do that, I need to do a couple of things over here. Number one, I'm going to make sure my 10 address is not advertised to my service provider, so I'm going to take it out of my routing, number one. Number two, what I'm going to do over here is I'm going to introduce a new network, that a loopback basically. I'm going to do it as a /32 that will be used as my tunnel source and tunnel destination to get to the other sites. And I'm going to advertise it to my ISP. So the only thing that I'm advertising to my ISP is that tunnel source address, so that it is reachable by my other peers. So let's take a look at what I'm going to do over here. First thing, if I go into my first hub, my first device, this is my hub. Let's assume this is my hub. This is my Dubai site. Right now, if you take a look at it, I am advertising the 10 network in my routing protocol. That is the PECE routing protocol that I'm running to connect my edge router, my CE router, towards my customer, my provider edge router. And in that routing table, I learn all the routes, the 10 fives. So my first objective is to get rid of that. So under router EdgeRP 1234, I'm going to say no network 10. So I'm not going to advertise my 10 network, neither on neither of my sites. So over here, I'll do the same thing on R6, router EdgeRP1234, no net 10. Do the same thing on 7, and I'll do the same thing on 8. Again, if you feel lost, go ahead and check out my first video where I'm setting this MPLS VPN setup so you can follow along. So I got rid of my network 10, that's my internal network that I was advertising through my MPLS VPN to my other sites. Instead, what I'm going to do is I'm going to run a DMVPN setup. That's where I'm going to advertise the 10 network. So if I go to 8 now, I should not see in my routing table any of those routes learnt through my public network, my not public, but my MPLS VPN network. Good. The only routes that I'm seeing over here are my local routes. The only D routes that I'm learning are my reachability routes to the other peers, which is, this is Dubai, London, Los Angeles, and I'm in New Delhi. All right, that's the first thing that I did. The next thing that I'm going to do is on each one of them, I'm going to create a loopback that's going to act as my tunnel source. So I'll create this loopback as loopback, let's say 10. And I'll give it an IP address of 172.16, let's say 1.1 or 1.5, 255, 255, 255, 255, and I'll advertise it in my external routing protocol, the PECE routing protocol. If I go to 6, IP address 172.16. All right, come on. 16.1.2 or no 1.6 because I'm using the same numbers to keep it simple. So 16.1.6. If I take a look at my routing table now, I should have learned the 172.16.16 network. Should also learn the 5 through EdgeRP. Why is that not coming up? I make a mistake. Yep, it should be 1.6 or 1.5, sorry. Alright, so if I go over here, I should see that 16.5, and if I do the normal one, I should see 5 as well as 6. Good. And let's do the same thing on 7 now. And I'm using loopback 10 for this. 172.16.1.7. I can be more specific and go to 8. Come on. 16.1.8. Alright, so at this point, I have this loopback that I am learning through EIGRP, but that's about it. My loopbacks, the 5, 6, and 7 on 8, and the public networks. That's all I'm learning through my outside network. I'm not learning any of the 10 networks right now because my plan is to run it through EIGRP. Good. And EIGRP, EIGRP that I'm going to run through the DMVPN tunnel. So with that in mind, what I want to do is I want to do this type of setup where I want Dubai to be my headquarters. I want this to be my NHS, the next top server over here. I want these to be my spokes. I want to run DMVPN phase 3, which basically is going to use NHRP redirects. This is my tunnel network, 192.168.1.0. That's what I'm going to use for my tunnel. This is my NHS. I'm going to start configuring R5 as my hub, which is Dubai. All the sites will form a neighbor relationship in terms of EIGRP with him. I'm going to run it in a different autonomous system and over the tunnel interface. Alright, the tunnel interface address is this, and that's where I'm going to run my the 10 network. So I'm going to advertise 10 through this tunnel network, not through my service provider. So service provider will have no idea that I'm running the 10 networks. So that way, by doing this, I'm going to isolate or hide my internal networks from what do you call it? From my service provider. So the 10.5 or the 10.55 that I have, oops, this is 6, sorry. And then 10.5s that I have over here, they will not be seen by the service provider, which was seen in the previous example. All right, how do I accomplish that? So let's go ahead and set, I'm going to use my notepad over here to create my tunnel network. First thing, interface tunnel, let's give it an ID of 1. The tunnel network, we agreed it's going to be 192.168.1. Let's say 5 for Dubai. This is my tunnel network. Tunnel source, I could have used the outside interface, the one that is connecting me to my provider edge, the PE router, as my source, but just to keep it more private, and it's going to help me, as I said, with my IVRF setup in the next example. What I'm going to do over here is I'm going to use a source as loopback 10, the one that I created and advertised to the other side. Tunnel mode, I'm going to use as GRE multipoint, MGRE basically. Alright, once I'm done with the tunnel source, tunnel mode, the next thing that I need to do is set up my NHRP, IP NHRP network ID I'll say is 100. IP NHRP map multicast dynamic for my EIGRP. IP NHRP redirect. I need that because I'm going to run EIGRP. I am also going to specify no IP split horizon because my routes will be learned from the tunnel interface and I need to send it back to my different spokes over here. And I'm planning on running EIGRP in AS100. Okay, I'm not going to do the tunnel protection yet. I just want to get the routes across. Once the routes are across, then I can go ahead and encrypt it. Oops. Once this is done, I'm going to run a different EIGRP process. I'm going to run it for 100. I don't need to do no auto summary. Network over here is going to be 192.168.1.0 and my 10. All right. Copy this on my hub. I am going to go to my hub, which is R5, and put it there. No IP split horizon EIGRP. All right, let's just do it over here. Let's paste it again, it's easier. Good, that takes care of that. My hub is ready. Let's do the spokes. Spokes, I need to do something different. So what I'll do is I'll copy this, but then on the spoke sides, this is 6. This remains the same. All this remains the same. But the thing about NHRP is, first of all, I need to specify my NHS, which in my case is going to be 1.5. All right, that is Dubai or the router 5. How do I get there? IP NHRP map 192.168.1.5. To get there, I'm going to use 192.172.16.1.5 as the address that I want to use to send it across. Map multicast, I'm also going to send my routing update to him. I don't need to do this over here because I'm going to be sending the routes. I'm not going to be redirecting the routes, but for phase 3 I need to put shortcut on the client side. The rest remains the same in terms of routing. If everything's fine, I should have this tunnel up and running between 5 and 6. Let's go to 6. Tunnel is up and my EIGRP is up. So at this point, if I take a look at my EIGRP, I have learned these two routes, but they're not learned through my Ethernet. Instead, they're learned through my tunnel interface. So tunnel 1 is where I'm learning these routes through. Although they're not encrypted because I'm just using GRE at this point, MGRE, I'm going to be encrypting it using IPSec in a bit. All right. Similarly, once I've set this up on one of the spokes, all I need to do is change the IP of the spoke. The rest, all of the configuration remains the same, because everything points towards the hub, Dubai, which is 5. Copy. Go to 7. Paste it. My tunnel should come up. My neighbor relationship should come up. And I should see my routes. And if I do EIGRP over here, just to see EIGRP routes, I have 10.5, 10.6, all learned through the tunnel, all learned through 1.5, which is the hub. You might say that creates a bottleneck on the hub, but it doesn't, because NHRP redirect, as soon as it receives a route from R7, which was meant for 6, it's going to send an NHRP redirect message saying, hey, listen, why don't you go directly to him rather than coming through me? Let me show you that in a trace. I'll do a trace route over here to 10. Let's say 6.6.6 with a source of, let's say, loopback 0, you'll see the first trace will have two hops, one towards 5 and then towards 6. But then at that time, I'll also get a redirect message back from the hub saying, hey, listen, why don't you go directly to 6? Because you have direct connectivity to 6. And then it does the NHRP redirect and goes direct. This is phase 3, by the way, DMVPN phase 3. So now I'm going direct. The first packet does go through the hub before the NHRP redirect message is sent. And the last device over here is 8. There you go. And I'll go to 8 now. And paste it. Line up. EIGRP should come up as well. Show IP route. EIGRP. And I'm learning 5, 6, 7 all through my tunnel interface, not through the hub. The beauty of it, if I go to any of the provider edge routers, the PE routers, and I check my VRF for that particular customer, they will not know about the 10 routes. They have no idea there's a 10 coming in. The only route that they know about is that loopback that I'm using for reachability purpose. That's about it. They have no idea about the 10 routes. So I'm hiding my routes. Now, although I'm hiding the routes, they're not getting encrypted. There's still clear text. So if I want to do encryption with that, I'll take that tunnel interface and apply IPSec to it. How do I apply IPSec to it? Let's do that over here now. In order to do IPSec, it's a 4-step procedure. Step 1, configure phase 1 parameters. Crypto ISACamp policy, let's say 10. Authentication, we'll say is pre-share. Hash, let's say is MD5. Group, let's say 2. Encryption, I'm going to use triple des. For my key, crypto ISACamp key, let's say Cisco 123. Address, I'm going to use this for all my tunnel peers. That's step 1. Step 2, configure phase 2 parameters. Crypto IPSec transform set, whatever you want to call it. Let's say ABC ESP-triple des ESP-MD5. The reason I'm calling it a name like ABC is I want to make sure you understand this is just a variable. You can call it whatever you want. So that when I use a word like ABC, that's basically a way of teaching you guys that don't think it's a command. It's something that you can make up. Then you call this transform set inside your profile. By the way, on the transform set, if you want to make it a little bit more efficient, you can make it into mode transport. Well, don't worry about that for right now. We can do it. It's better, more efficient. But my objective over here is just to keep it simple so that you understand the concept. So configure an IPSec profile. Here I'm going to attach whatever you want to call it, III, set transform dash set to ABC. Again, the reason is I don't want you to confuse that. It has to be called the same as your transform set. Could be anything as long as you call it. Now, last step, apply the IPSec profile to the tunnel interface, which basically says any traffic leaving this tunnel should be encrypted by using this profile. So my tunnel over here is tunnel 1. Let's say tunnel protection, IPSec profile, and I called it III. I'm going to copy paste this to all my devices because there's no parameters over here that are specific to a device. All of them are generic parameters that everybody needs to have for encryption to take place properly. So I'll go over here. We'll start with the hub, which is R5. Let's take a look. See, it's saying, hey, received an IPSec packet, a non-IPSec packet, which was supposed to be IPSec. So eventually all the tunnels will go down, right? Because one side is doing it, the other side is not. So what I'm going to do is I'm going to copy this and paste it to all the other devices as well. So they start encrypting now. There you go. The neighbor relationship is up. Show IP route EIGRP. I'm learning the 10.5. I'm not learning the other ones because I haven't done encryption on that. The other thing you can also check is show crypto sessions detail. All right. Shows you that I'm not using any front door VRF or IVRF, the internal VRF. That's for the next lecture. All right. We'll take a look at that. The only one that's up right now is the one towards 5. The other ones are down because I have not configured it on the other ones. So let's go ahead and do the rest of it. Copy it. I'm going to paste it to 7. And I'll explain the concept of front door and the internal VRFs in the next video. Come on, paste it. There you go. Should be up. My neighbor relationship is up. So again, if I do show IP route EIGRP, I should see the 10.5 and 10.6. Not 10.8 yet because 10.8 I need to apply it. Let's apply it over here. There you go. So I have all my tunnels up. All of them are encrypting. And if you want to check, I have no front door VRF, no internal VRF right now, because right now I'm just doing a normal MPLS VPN. I've laid DMVPN on top of it. Two advantages of doing that. Number one, I'm hiding my private addresses. My private networks are not getting exposed to my service provider in the PEC routing protocol. Number two, I am encrypting the traffic as well. MPLS VPN does not encrypt traffic. It just segregates traffic from different customers that belong different customers at the service provider level. So it's just isolation from your traffic of your traffic from the traffic of other customers of the ISP. With DMVPN, you have hidden your internal addresses from the service provider, plus you have encrypted it as well. All right. So if I do a trace right now, trace route, you won't see any of the routers in the middle. You're going to directly go to the tunnel interface. So I hit 1.5, which is directly the tunnel interface of router 1. Cool? You guys good with this? This is your DMVPN in conjunction with MPLS VPN. Again, as I said, this has nothing to do with the front door VRF or the internal VRF. That's why when you do show crypto sessions detail, you notice that they're both at none right now. And slowly, I'm going to do the internal VRF and the front door VRF as well. That's in the next videos. So this is basically a video for your MPLS VPN in conjunction with DMVPN to hide your internal networks and encrypt the data. In the next video, we'll explore the concept of VRF Lite, which is on the service provider level. In that particular video, we'll get introduced to the concept of IVRF or internal VRF. All right, keep watching. Again, if you want any other videos that I might have that might help you, as I listed before, send me an email at khawarb@khawarb.com, and I'll be more than happy to share them with you if I have them. All right? All right. Thanks for watching.